This video explains crashing. So what is crashing? Crashing means if management or customer want to finish your project by certain weeks, then you have to decrease certain activity duration, then you can complete a little bit early, that is crashing. For example, we have this example, we have activity A through K, and out of this, some activity is crashing is possible. For example, activity B, their possible crashing periods 1 means they can finish by expedite by 1 week, means their current duration is 6 weeks, but if they crash this activity, then they can complete by 5 weeks. For example, activity F, so you can crash activity F. You can crash 1 week or 2 weeks. It's based on your requirement. Then your current duration is 8, but you can expedite by 1 week or 2 weeks. But it costs $2,000 by crashing 1 week. So if you crash 2 weeks, it costs $4,000. To solve this problem, first of all, you have to generate, you have to construct a network, right? AON network, here is network. So you have a 3 paths, A, B, E, F, G, K, A, C, D, F, G, K, A, H, I, J. These 3 paths. Out of this, the longest path is your critical path. Also, we can use, we can compute ES, EF like this, EF, EF, LS, LF. Then to do that, you have, we complete this kind of Excel spreadsheet, activity, duration. We need the predecessor informations. Then we can compute the ES and the EF. So activity A, B, C, D, E, F, D, H, I, J, K, and durations 2, 6, 4, 3, 2, 8, 5, 4, 10, 3, 2. So these are durations, predecessor, none. And we have A, we have A, we have C, A, C, B, E, D. Means if you have to start F, you have to complete E and F. So that is predecessor. F, A, H, I, G. So first of all, activity A, there is no predecessor, means you can start right now 0. Then earliest finish time is equal to ES plus duration. So you just complete this. And then now you have to take into account their predecessor. For B, you have to finish A first. That means you have to finish A first, then you can start. C, you have to finish A, then you can start. For D, you have to finish C, then you can start. B, for E, you have to finish B first. You have to look at this predecessor. How about F? F case, you have to finish both of them. That means you have to take a maximum number of E and D. And F, for this case A, for this we have H, for this we have I, for this we have G, where is it? This one. Then you have this information. You just compute ES, EF. But now you need some successor information to complete LS, LF. Latest starting time, latest finish time. So for this, the last ending point K and J, their last point, this ending point, their LF should be equal to their EF. So for K, LF is equal to this 25. How about J? J also their LF is equal to their EF. Means they have to finish up to this point, their earliest starting point. You don't need to finish no later than this time. But now LS is equal to simply LF minus their duration time. And also to compute each LF, we need their successor information. For A, their successor, A successor, B, C, B, C, H, B, C, H. For B, successor E, C, D, D, F, E, F, F, G, G, K, H, I, J, J, none, K, none. So for none successor, there is no successor, they have to finish at this point. For I, so their successor is J. J, they want to start 16, means their latest starting time should be this. How about I? For H, their successor is I. That means they have to finish at this point. For G, their successor is K. So that means they want to finish up to this time, 23. Right? For F, their successor is G. Then you can finish by this point. For E, their successor is F. So that means you have to finish by 10 because they want to start at 10, right? D, their predecessor is F. So you have to finish by this time. For C, their successor is D. You have to finish by this time. For B, E is their successor. So you have to finish by this point. For A, you have 3 successor. That means you have to take a minimum number of these. You have to take a minimum of this number. Or C, where is C? B, C, and where is H? Check again. I made a mistake. B, C, H. And for B, successor, this is wrong. For B, their successor is E. E is here. So we have this number. The now you can compute the slack number. Slack will be ES LS minus ES. Or in other words, you can compute slack number LF minus EF, means the difference between earliest starting time or earliest finish time. Then for this case, LS minus ES, and for this case, LF minus EF. Then with this, so you have this slack time. That means C and D has some slack time, but others finish time. I want to change J's LF. Actually, the longest time, will be 25. So this J also, I will change LF with 25. So I will change this number. Then if you don't have any activity on J, then for this case, you have a lot of, kind of, even if they do not have any kind of relationship, but finally, if this project is independent, you can finish up to this point, but otherwise you have enough time to complete by 25. So at the beginning, I said for this case, there is none, but you have to choose the longest LF. So I will change this number. Then you change this number, then you have this kind of, activity has slack time is 6. So I fixed this number. So then here we have ES, EF, LF, LS number. Now think about our crossing, to apply crossing idea. So you can apply here. I mean, you can change duration, then you can complete the final duration here. Instead of those individual approach, we just use some path idea. So here we have some certain path, and we have also activity A, B, C, D, E, F, G, H, I, J, K. And activity A, the original 2, 6, 4, 3, 2, 8, 5, 4, 10, 3, and 2. So this is actually our original, and our crushing time, crash week. So you apply this crash week. Also, if you have crash week and also you have crash cost. For B, crash cost is 500. D, crash cost is 800. And F, crash cost 2000. And G, crash cost 700. I, 300. We have those crashing costs. And we can consider our possible path. So actually we have 3 paths for this case, fortunately. So here also, if you have original and if you crash some activity, then your duration will be your original minus crash cost, right? So now we have A, B, E, F, G, K path, A, C, D, F, G, K, and A, H, I, J, K path. And now these are your path. And now you add the name first. To add name, so you just add this number and create from selection. And your name is from right column, so you can complete this. And the year duration, actually original minus crash week, right? And this is your duration. Currently there is no crashing, so that's why we have original and duration are the same. And also you can compute, you can add the coefficient 1 for this activity. A is 1, B is 1, E is 1, F is 1, G is 1, K is 1. So next, A is 1, C is 1, B is 1, F is 1, G is 1, K is 1. So for third one, A is 1, H is 1, I is 1, J is 1. Then now finally you can compute what? Sum product of duration, comma, and this coefficient means, this means 2 times 1, 6 times 1 plus skip, and the 2 times 1 plus 2, 8 times 1, 5 times 1 plus 2 times 1. So this is whole duration. So out of these, which one is the longest path? Actually, the first one is our longest path. Actually, the first one is our critical path. And you can compute also possible crash week is actually B is up to 1, D up to 1, F you can crash by 2 weeks, G1 and I 2. So based on this crashing, so now we are, you can say this activity A is critical path, critical activity. B is also critical activity. E is also critical activity. F is critical activity. G is critical activity. K is critical activity. Based on this, and if you decrease one of these activity, so let me crash activity B. So by 1 week, so you just type 1 here, then what happened? So you type 1, then your final duration for activity B, it will be changed to 5, right? Then our total duration, so will be changed to 24, the original 25. That means if you decrease any activity duration, critical duration, then you can finish early. But if you finish a little bit early for non-activity, non-critical activity, for example, you can crash activity I, but actually activity I has the longest time. So you can finish, you can crash by 2 weeks here, then your total duration for activity I will be 8. What happened? Nothing happens here. Still, your total duration is 25. So means what? If you finish or you can crash a certain non-critical activity, it doesn't help. Means what? So here again, theory of constraint apply here. Right? So now that means our goal is what? You have to complete this project within 23 weeks. And now you have your current duration is 25. You have to finish 23 weeks. To do that, you can decrease one by one. But however, you have to focus on critical activity. First of all, you can finish B. So you can finish B1. So crash by 1 here. Then what happened? You crash 1 week, totally 24. So you need to crash 1 more week. Which one? So can you crash activity E? Yes, we try. So we can try activity E, but E case it is non-critical, so you cannot change here. How about F? You can change. You can crash 1 week here. So what happened? So if you crash here, then finally you can complete by 23 weeks. So this is a possible scenario. You finish B1, also you can finish F1, then your total cost, it will be, you have to compute the total cost, total crash cost will be simply some product, again, some product of crash week, crash cost, and crash week. Then for this case, your total cost is 2,500, and you crash B. Also, you can crash G as well. So try to change G here. Then what happened? So you can crash B1 first, then you can crash G1. Then this total cost is 1,200. 1200. And what else? So you can crash I, but it would not help, right? Then another possible scenario. So we finish B1 first. Now we are done. And now we can change F first. You can finish F 1 week. Then another possible scenario will be you can crash one more week for G activity. Then you finish F1 and G1. Then what happened? The total cost is 27,000. Or you just crash activity F by 2 weeks. Just activity F 2 weeks. The total cost 4,000. So out of this whole scenario, so you have to spend more money to crash, but however, this combination you can crash 1 week, you can crash B and G by 1 week respectively. Then your total crashing cost 1,200. So this is your best scenario.